Thank you for introducing me. I am Shazibul Shamim. I am a second-year PhD student at Tennessee Tech University. I started my PhD at Tennessee Tech University in spring 2020. So currently, I'm a second-year PhD student, and soon I'll be in the third year of PhD student. So before joining the PhD program, I worked as a DevOps engineer back in Bangladesh for 3 years. Then I joined PhD as almost a DevOps domain. So let's get started. So let's start with a simple overview of an application infrastructure. So what happens is client connects to server via internet. So client means the user. User means user connects with mobile, laptop, or desktop computer, and they connects with the server. In server, there are some applications running, and the servers is a giant computer with hundreds gigabytes of RAM and very strong CPU. In the top of the hardware, there runs operating system, and top of operating system, there runs applications. So who builds the applications and who maintains the applications? That's a question. So there comes development and operations team. So development team, who are software engineers, who plans the software, gathers the requirements and code and builds the software and deploy and test the software and hand it over to the operation team. The operation team deploys the software in the infrastructure, and they make sure the applications are running properly and it is accessible by the user. And they monitor the applications in case it fails. So there comes a conflict. Development teams want more agility, and operations team wants more of stability. So these are conflicting things. So another things, this leads to the problem of environment conflict. For example, if a developer says that it works on my machine and the operations team says that it doesn't work or it doesn't properly work, then there is a conflict. Another thing is when one team working on some different technologies, for example, like Python, another team was working with Java, then there might be possibly a conflict of version or something, a configuration related mismatch. That's why virtual machine came in. Virtual machines allows to create independent abstract machine, which works like similar to a real computer. Each virtual machine has its own virtualized CPU, virtualized RAM, and applications runs on top of in each of the virtual machine, so that the problem is completely solved. With the growth of technology, container came in. Container adds another level of abstraction. Instead of using as a different operating system, container uses host operating system and for example Docker, and uses adds all the necessary to run the applications. As the software engineering community is gradually going towards monolith to microservices, which are independent and loosely coupled, container-related containers such as Docker are very popular for deploying application. So that's the evolution of application deployment. Typically, in a operations team deployed application on bare metal operating system on top of hardware. Then come virtualized environment for that helps optimally utilize the resources and scalability, and also making sure that each environment separation. And then come container deployment. It adds another flexibility on top of virtualized deployment. It helps in its container is highly flexible, so that it can run independent. It packages all the software and dependencies so that application can run independent of the environment. So why container orchestration? So say end users connect with front-end applications, and front-end applications are connected with back-end applications, and back-end applications connects with database. So that's the simple applications. That's the simple architecture. But in real world, there are lots of applications. For example, like Uber has 500 instances. So real world applications has hundreds of services. That means hundreds of instances, hundreds of backend applications. Each application is independent and loosely coupled. They can communicate with each other. So to maintain that application, we need to manually define the IP configurations, load balancer, and storage architecture. We also need to manually define the number of instances of a container and what will happen if a new service comes and what will happen if suddenly a container dies or due to malfunctioning. What will happen if what will happen if suddenly host collapses and how to reschedule the containers, and what will happen, how we can manage the configuration of the containers, and what was the most important thing among the hundreds of containers running in the servers. How can we troubleshoot if one container failed? How to know which container fails? So there comes the need for container orchestration. So containerized orchestration is there is an orchestrator who will orchestrate the applications running on the nodes like servers, and it can be managed with configuration files. Here comes Kubernetes. Kubernetes is an open source software for automating deployment, scaling, and management of containerized applications. Kubernetes was initially developed by Google back in 2014, and it was open source, and then it is currently maintained by Cloud Native Computing Foundation since 2015. So here I'm discussing about Kubernetes architecture. So practitioners uses Kubernetes, so command line kube control in a utility tool, or Kubernetes dashboard, which is a visual dashboard, and they communicate with a control plane node, that is control plane node, and that there is another node called worker node. In control plane node, there is a component called QAPI server. It's the heart of the Kubernetes Kubernetes, and it maintains all the communication with others through application programming interface or API. So in control plane node, which is the main whose work is to maintain all the nodes of the all the nodes and worker nodes where the containers run. In the control plane node, there are 4 components: Kube Scheduler, Kube API Server, etcd app, and Kube Controller Manager. Kube Scheduler helps scheduling the schedule where the container will be scheduled. And the Kube Controller Manager manages the state of a cluster, how the container should be, how the container should be, how the container should be run, what is the state of the cluster. And etcd stores all the key and configuration of the cluster. In worker node, there are 3 components: pod, kube proxy, and kubelet. Kubelet ensures that pods are running properly. Pods are the smallest entity in a Kubernetes cluster. Inside pod, containers run. And kube proxy ensures the networking rule of Kubernetes cluster. What is the benefit of using Kubernetes? Kubernetes is highly used software in industry. So Capital One, IBM, Booking.com, and the top tech company Netflix, Pinterest, and Spotify uses Kubernetes for the regular deployment. Kubernetes is also used by federal organizations such as the United States Department of Defense. The United States Department of Defense reduced their release time from 3 to 8 months to just 1 week using Kubernetes. According to CNCF 2020 survey, 91% of respondents currently using Kubernetes, compared to which 78% in 2019 and 58% in 2018. According to 2021 Kubernetes Adoption Survey, 89% of 500 respondents said that they use Kubernetes to deploy their AI-based applications. Kubernetes also has 77% of market share in container orchestration technology, compared to its opponent, Mesos, which is maintained by Apache Foundation, and Docker Swarm, which is maintained by Docker, and OpenShift, which has only 9% of market share. According to another survey, 78% of practitioners say that Kubernetes is a clearly go-to choice option for container deployment. Kubernetes also has a vibrant developer community. Kubernetes is also considered one of the fastest growing of open source software in the history of open source software, and it has got 2,000 of participants from Fortune 500 companies as a contributor. According to this report, It suggests that Kubernetes-related job searches increased by 2,125% in last 4 years. And according to another survey, Kubernetes is popular not only to the large tech companies, but also to the small and medium-sized companies. Its survey says that 37% of small companies and 43% of medium companies and 20% of large companies use Kubernetes for the regular deployment. And the survey was conducted among 24,441 companies among the world. So what is Kubernetes manifest? So Kubernetes allows programmers to write code and they use that code to maintain, configure the cluster. So there is an example of a Kubernetes manifest. So Kubernetes manifest, we can see that in Kubernetes manifest, there is a kind, for example, like you can define the kind, you can define specify your container, your image, and what are the command line tool. In the example we have shown, it's a insecure Kubernetes manifest. It's provided privilege root privilege to the container. So these sorts of insecure configurations in Kubernetes manifest is quite common, as we have found, and it's also concerns the developers. In the CNCF 2020 survey, it suggests that 40% of developers practitioners are concerned about their Kubernetes security, and it is the second major challenge in adopting Kubernetes. Also, practitioners are in 2020 survey suggests that practitioners are really concerned about Kubernetes security. In Red Hat 2021 summer survey report suggests among 500 DevOps and IT practitioners around the world suggests that 59% of the practitioners detected misconfiguration before deployment in their Kubernetes cluster. And 32% of respondents said that they faced a security incident during the runtime of the application. And 31% practitioners said that they have one of the major vulnerability they found major vulnerability in the Kubernetes cluster, and they have to stop to deploy their application before fixing it. And 20% of the respondents reported that Kubernetes they have failed audit in their Kubernetes insecurity incidents. And only 6% respondents said that they don't face any security related issues. So overall, 94% of respondents face some sort of security misconfiguration related challenges in Kubernetes cluster. So Kubernetes security attacks is also is prominent in Kubernetes cluster. For example, in 2018. Amazon Tesla cloud resource was exposed to a hacker, and they exploited the Tesla's Kubernetes cluster and injected crypto miner, and that caused a huge amount of loss to Tesla. And this in recent 2021 report suggests that Kubernetes cloud cluster can face cyber attack due to Argo workflows, because this dashboard is exposed with misconfigured dashboard is exposed outside the world, and the hackers can easily access that cluster and deploy their own applications such as crypto miners. So as a first part of our research, what we did a literature review survey in Kubernetes. We searched with Kubernetes security and Kubernetes adoption, this sort of keyword in the top 5 scientific database: ACM, IEEE, ScienceDirect, Willy, and SpringerLink. We gathered 27,398 search results, and we removed the non-peer reviewed publications, and we collected 19,771. After removing the non-English publications and publications available for reading, we finally gathered 19,692 publications. And after reading the title, we collected 457 articles. And after reading the abstract and introduction of the paper, we gathered 181 papers. And finally, we gathered 105 academic publications for Kubernetes publications. As Kubernetes is highly driven by software practitioners and open source community, we also look into the look into the internet artifacts such as blog post videos, as for to know what's the developer are concerned about, what they discuss about. So we search with the same keyword in the internet, Google, and we apply filtering criteria such as how is we read the article and say how is this article, blog post or video relates to Kubernetes, and we gathered 321 internet artifacts. So this is our entire process. So we gather the research publications, we apply filtering, we perform qualitative analysis, we perform the quality of each of the articles and academic papers as well. We apply qualitative analysis, and we come up with list of challenges and benefits of Kubernetes, and also the application areas, and what are the potential research areas that are currently being conducted in Kubernetes. And we also observed a gap in security analysis in Kubernetes manifest while we conduct our literature review. This is the one of the staggering outcome of our research, that we found that practitioners are mostly concerned about security. For example, like lack of security practice and tools, 132 practitioners have described, and 126 practitioners described that about attack surface reaction. And we also find that learning curve is also a crucial challenge to Kubernetes users. After that, we also found what are the existing research in Kubernetes. We found that only 7 publications among 105 publications discuss about security, which is comprised only 6.7% of the whole academic publications. They mostly discuss about performance evaluation, resource allocation, Internet of Things, machine learning, and microservice orchestration. So we were interested to find whether we can find the vulnerability, or we can find insecure configuration in the Kubernetes manifest. So what we did, we parsed GitLab repository, GitLab, with certain criteria, such as we first say that if we set the label to Kubernetes, and whether the repository is available, and if it is not cloned and the repository is active, that means if the repository has 2 commits per month and it has more than 5 contributors, then finally we collect the repositories. So in applying the filter, we collect 38 repositories. So from the 38 repositories, we found 1,796 Kubernetes manifests that are modified with 5,193 commits. So this duration is since 2015 to 2020, as Kubernetes is released in 2015. So this comprises our whole criteria, the whole process. We mined the GitLab repositories, we curated the repositories and performed qualitative analysis, and we labeled each of the commit messages insecure or neutral, based on, for example, what type of keyword, or what type of commit message they put into the commit. So what we found is we identified 41 commits to be labeled as security dataset, and we found 39 Kubernetes manifests to be modified as security defect. The proportion is 0.79% of the total parsed repositories manifest. So we cross-checked this with 2 raters, and the correlation is 0.7, which is significant. And after discussing with each other, both of the raters confirmed with each other. After performing this, we went to check what are the security practices developers typically work with. As I already said, Kubernetes has highly driven by developers. So what we did, we searched with Kubernetes security best practices, Kubernetes security practices, this sort of keywords in Google, and we filtered 104 internet artifacts after reading 300 more than 300 articles For each keyword, we curated top 100 results. So that's why how we filtered 104 results, internet aspects that relates to Kubernetes security best practices. And we performed quality analysis and gathered and come up with 11 security best practices. So these are the security best practices that we have come up with from what developers have said and demonstrated in their articles, blog posts, videos. We've found that authentication and authorization is the most discussed security best practices, which is 82 practitioners among 104 described. And also implementing Kubernetes specific security policies. 81 practitioners said that Kubernetes specific security policies such as port security policy, networking policies should be implemented in the Kubernetes cluster for security. We also, the developer also suggests vulnerability scanning of the container so that if any malicious container running in the, so that malicious container does not propagate into the system. They also suggest logging and namespace separation and restricting and encrypting its access to HCD so that a cluster information and secrets are protected. They also, practitioners also say that if the applications are not updated properly, then if this is an open source software, in any malicious actor can attack the Kubernetes cluster if it is not properly updated with security patches. They also said that to limit CPU and memory quota for each of this container. They also said that enabling SSL TLS support for each of this container to protect from man-in-the-middle attack. They also said that they also suggest separating sensitive workload and securing metadata access in case of cloud API, cloud-based applications. So in this talk, I will discuss few attacks and corresponding threat models. So one threat model is for misconfigured role-based access control. So what is a role-based access control? So role-based access control is defining particular role to an user, which a user will use to perform certain action. A role-based access control is a built-in feature in Kubernetes. It defines a proper authorization mechanism for all the users in the Kubernetes. So if a user does not have proper role-based if a Kubernetes cluster does not have role-based access control defined for all of the user, then it can happen that some of the users will have overprivilege. And the overprivileged user will have some unnecessary permission to perform an intended action. For example, like in this scenario, if we consider a user who can access Kubernetes dashboard, and he may have his admin configuration, and already according to the Kubernetes official documentation, the documented installation process of the Kubernetes dashboard is by default, it provides default admin permission to the user. But they also tells the user to not to use that default configuration, admin configuration in the real world setting. But if as we already said, the learning curve is a one of the challenge for developers. If they apply these settings in the real world applications, what will happen? So let's consider a situation when a user installs a Kubernetes dashboard as per default installation as described by Kubernetes documentation. So by default, the user will get admin privilege. So as the user will get admin privilege, so he can do anything in the cluster. So this is what the similar thing that happened to the Tesla. The user got overprivileged. The user got they have also another additional thing. So they have exposed their dashboard outside the cluster, and the dashboard was not properly protected with RBAC. So what happened is malicious user entered and inject crypto miner in their cluster. So in that case, similarly, we can say that the user can run malicious applications such as crypto miner inside the Kubernetes cluster and cause massive financial loss, or it can delete a container, or it can do many things, certain operations that root Kubernetes administrator can do. So let's think, look at the attacks for misconfigured RBAC. So a malicious user who gets access to Kubernetes dashboard can also get access to Kubernetes control plane. As you know, control plane node is the heart of the Kubernetes cluster. In Kubernetes control plane, there is Kubernetes API. So with the malicious user with the Kubernetes access to Kubernetes dashboard can access the Kubernetes control plane node, and it can also deploy nodes in the container. For example, like in the default namespace, there is 2 applications are running. So malicious user can inject a new applications or crypto miner in the worker node. And so that's the problem that can happen due to misconfigured RBAC. So next we can consider misconfigured pod. So when configuring pod, there are 2 specific things we need to two terminology we need to familiarize with. One is pod security policy, another is security context. So pod security policy is Kubernetes cluster level resource that defines what rules and regulations pods must comply to run in the cluster. So pod security policy ensures that pods are conforming some rules and regulations that are necessary to perform for security maintain security in the cluster. And security context inside the pod defines that whether the container in the pod have right level of access and privilege. If a container can have, which security context is not defined, then the pod may have some default permissions and root so that over privilege, and if any malicious user can get access to the root container, can perform some malicious activities. So let's consider a pod is running in a cluster without security context or without pod security policy. So what can happen if a malicious user has permission to view and deploy a container, just this permission? So typically in this context and all this discussion subsequent, we are considering not outsider threat, we are considering the insider threat. So it can be any malicious user. Malicious user can be any trusted employees, any any user that any compromised malicious user can be. Maybe he mimics a trusted employee. So if the malicious user has the permission to view and deploy container, then if the properly security context is properly not defined, then there may be that it is possible to perform remote code execution with some certain commands such as kubectl exec in the container, and the malicious user can copy them, get into the host storage system and copy the mounted host volume into the container storage. And that's how the user can get access to the sensitive information of the host file, as well as the entire of the host file system, as well as they can compromise the entire cluster. So what is how the attacker can do if the pod is misconfigured? So if for example, malicious user will access with the proper credential, for example, like he mimic or somehow he bypass the authentication system to get access to Kubernetes serial and Kubernetes dashboard, and then he will access to Kubernetes control plane, and then with the control plane he will for example, he will access the default access the worker node. Maybe, for example, consider in this case, in the container, there are one application is running, which is a secure application, and a corresponding database. So first, let's say there is another application is running, that is root privileged application. So what an attacker can do is he can get into the if shell. He can if the remote code execution is not not disabled, then a hacker can get into the pod in the root privileged application, and what can happen? He can mount the host file system inside the root privileged container and compromise all other applications and databases. So root privileged applications should not be used. So practitioners strongly suggest to disable this root privileged container root permission to the container and so that the containers might not break out and exploit the host system. So another thing is how can the attack happen in the default namespace? So the namespace creates a logical isolation in the Kubernetes cluster. So typically, if you do not specify a namespace, then the application runs in the default namespace. So for example, if a malicious user gets access to Kubernetes cluster, then so it can get access to the worker node. So what is the standard practice here is to create a separate namespace for separate team. For example, like if you have a developer team, you will, for example, then you can create a namespace dev namespace. So if you have a name with if you can if you have a production team, you can name it you can name as production namespace. So each namespace is a logical isolation. So applications on database inside one namespace may not necessarily communicate with other namespaces. So, so if one user has one user or one employee has access to one namespace, he may not be able to get access to another namespace. So that's why it's necessary to create namespaces. So if no namespaces is defined, then by default Kubernetes assigned is default namespaces. So if you do not define anything, then Kubernetes will automatically schedule the application in the default namespace. So if you do not define applications in the namespaces, then what will happen? For example, like in this case, you have two applications. One is front end, another one is back end. So if there is another application is running, that's the database. So what can happen is that if any malicious user can get access to the default namespace, he can also exploit the sensitive applications such as database from the namespace. So the default namespace should always be avoided. So let's talk about a network policy. Network policy controls how network traffic flow inside Kubernetes cluster. By default, all pods in the Kubernetes cluster can communicate with each other, and network policy enforces rules how the pods should communicate with each other. So if network policy is not defined, for example, like which it will be what will be the rule for inbound network and what will be the rule for outbound network, then a malicious user can take this as an advantage to exploit the Kubernetes cluster. So let's consider in an organization there is no network policy defined in the Kubernetes cluster. So what will happen if the malicious user who has just a permission to deploy a pod can eventually access other pods which is in different namespace and request for a connection? So if they can request for a connection, then they give this can lead to successful connection if they perform some brute force attacks, say in the open port, or hamper the overall application network flow with unnecessary traffics. So what is the possible attacks for undefined network policy? So again, malicious user will get access to Kubernetes control plane node, and then with the Orca node, for example, like in namespace B, there are 3 applications running: a front-end application, application X, application Y. In another namespace, namespace A, they're running the backend and the corresponding database, and the only allowed network is from namespace B. The front end will communicate with front end B. Front end will communicate with backend from namespace B to namespace A, and within namespace A, backend will connect with database. If namespace not properly defined, then what can happen is that applications from pod namespace B front end can try to access database running in the namespace A, and the application X that you can also wants to connect with backend of a namespace in the namespace A and the database running in the namespace A. So to protect this, we need to implement practitioners suggest we need to implement network policies so that pods who can communicate with other pods is properly defined. Without network policy, pods can communicate with each other. So we need to stop that. We need to define proper input ingress policy. Whose connection, which connections will I accept, and which connection will outbound from it, that is egress policy. That should be defined in network policy. So another threat model is etcd secret. So as I have told earlier, that etcd contains all the secrets and the backup of cluster information in the Kubernetes cluster. So whatever the actions, whatever the is already, all things are saved in the Kubernetes etcd database. And by default, the secrets in the etcd database and the informations are not secret by default. So in case, let's say a malicious user compromised, a super strong and very skilled malicious user compromised the host of a Kubernetes cluster, then if etcd cluster is not protected with a third-party key management service, management service, for example, like HashiCorp Vault, then the hacker can access all the cluster information and potentially leak all the information and secrets of the Kubernetes cluster. So here's the potential attack for Kubernetes for unencrypted etcd. So let's say that here's the control plane node, and here's the Kubernetes API server that connects with worker nodes. And inside the worker node, there is kube scheduler and kube controller manager, and all the information the kube API server does is written into the etcd database. So if for example, like a Kubernetes API server will all the worker nodes, whatever they're scheduling, whatever the state that will be written into the etcd database. And in this case, if a malicious user compromise the control plane node, then eventually what will happen, that he will get access to etcd database, and he can get all the secrets and key and cluster information in the raw text format. So that will be detrimental for the organization, as well as he can replicate the cluster with using all the available information he has with them. So practitioners recommend that, and Kubernetes official document suggests that etcd database and at least etcd keys should be further encrypted with third-party key management system, so that in case of any cluster compromise, these secrets do not get leaked. So let's discuss about resource limit for pods. So by default, Kubernetes suggests to specifying resource limit so that it can restrict a pod to consume a reasonable amount of allowable resource. So if the resource limit is not specified, then one application may consume most of the resource of the host. So let's say a developer deployed a pod without a resource limit that contains malicious code, or a malicious user who has permission to view and deploy and delete the pod in the namespace. And so that this malicious user can inject malicious code into the container, or the running code can consume up all the available resources in the node. And this condition can lead to denial of service, DOS attack, because it will lead because one application consume up all the information, so that other running pods will go to the starvation, because they will not get enough CPU or RAM resources, or not enough networking resources to operate properly. So let's say a malicious user get access to Kubernetes cluster with kubectl or Kubernetes dashboard, and in the worker node, there are two containers running. So one container contains some without resource limit, and there is some malicious programming running. So even if in that case, if malicious user get multiple instances of the same container, then what will happen is that it will consume up all the resources and cause denial of service attack. So resource limit, it is extremely important to define the resource limit for the container, so that if in case of any malicious activity, the containers doesn't this doesn't lead to denial of service attack, or so that other pods goes to a starvation due to resource shortage. So in conclusion, well, I would like to say that in this research, we demonstrate that what are the does Kubernetes security best practices violation can actually lead to a real world exploit. So in this research, we demonstrate that yes, if you violate the security best practices, then yes, it can actually lead to security exploit. In this future work, we'd like to explore more novel attacks for security best practices violations, and in the potentially in the Kubernetes manifest, and I would also propose what are the mitigation strategies. So in summary, we said that we demonstrated what are the motivations and what are the evolving communities gather around to use Kubernetes, and the potential, and however the Kubernetes is still susceptible to security attacks. And we found that we also demonstrated that security best practices, what are the security best practices that developers suggest we need to follow. And we also demonstrated that no, it is real that if you do not follow security best practices, this can actually lead to attacks. So thanks for attending my presentation, and I'd like to have questions from the audience.